we've been talking lots about segments and lengths of segments. Well, today we're going to get into angles, because really lines and angles together make up every shape, and so that's why that's coming next. And so when you measure angles, you know what we normally measure angles in? Like what unit we measure angles? Degrees. And on the next slide, which you can kind of already see below there, I actually drew an angle, and we'll label these words that we've just done. But a part of a line which has one endpoint and one end that extends infinitely, right, like this. Name the endpoint with first. Oh, let me get her to give you the answer. What's it called? It's called a ray. It's when one side stops, so one side goes on forever. And the reason that you have to know what a ray is to talk about angles is the way we define an angle is two rays that share an endpoint and extend in opposite directions. Oh, those are called opposite rays. Just kidding. I thought it was going to be angle. That's funny. So they're saying opposite rays. Yeah, Chandler says that's just a line. You have one going this way and one going this way. That's just a line, or it's opposite rays.
You know Star Wars? The TIE Fighters?
I don't. I've seen it, but
it's like what? Vader cleared whenever.
Oh, this is the one I
destroying it. Yeah.
Okay. An angle is formed by two rays, says non-collinear rays, that have a common endpoint. And again, we're going to draw that out on the next slide here, but think about an angle, one ray going like this, and then another ray going somewhere else. Those are both rays, but they share that endpoint together. It says non-collinear rays, but couldn't you have an angle that looks like this? Couldn't that be an angle? I think I disagree with that definition, because that's just 180 degrees, right? What did I hide here? Oh, sides of an angle are rays. I know, I read it and then I'm like, what's it's a surprise.
But they could also be line segments.
They could be.
So, boom.
Do you know what this point is called? The common endpoint on an angle? Starts with a V.
Vertex.
And then on Friday, we talked about a bisector of a segment. This says a ray or line that divides an angle into two congruent angles. Guess what that's called? Or an angle bisector. So like if I drew in a line here, that could be my bisector if those two were the same. Have you done a little bit of stuff with angles before? Have you ever measured with protractors before?
We've tried to in science, it just never failed.
Okay, we're going to do it today. So
Protractors are not your friend.
they are our friends. Okay, so here's my lovely angle here. Right? Usually we have 3 letters on it because you would name a ray. Okay, let's go back to the rays for a minute. I kind of jumped over that. Oh, look at all this appeared again. When you name a ray, it says name with the endpoint first and then the other point on the ray. So if this was like A, B, you would name that as A, B, and you would actually draw it as a ray so that when you name it, you know A is the point that has the point and B is the line that goes forever. Does that make sense? So we know to name a line, we put arrows at both ends. To name a line segment, we just put a segment above it. To name a ray, we do it like that. So B is the vertex of that angle. And I don't agree with this typing here.
Gotta love the Rav.
Go
Rav.
Ray BA, which is like this with the arrow above it.
And Rav BC.
And Ray BC.
Rave.
I just hit it. Watch, it's gonna be back in just a minute. Oh look, why does it say like that? Oh. I put the arrows on underneath it, but say the word ray in front of it, you don't need the segment above it. If you don't say the word ray in front of it, then you need the segment above it.
Yeah.
Here's what I find annoying about geometry. There's so many ways to write things, right? It's a lot of stuff to remember. Here's the big thing I want you to know. We've talked about naming points, naming lines, naming planes, naming an angle. You can, you know, Taylor?
What?
You have a question, comment?
Well, I was, and then you put me on the spot, and I can't remember.
When you name an angle, you can name it with points. You have to make sure that the vertex is the middle point. So let's see. I think I have lots of ways to name this angle here. They might all show up at once. Oh, they did. We could name this angle angle ABC or angle CBA. Notice the B is in the middle. The letter in the middle tells you what the vertex is. You can also just name it by its vertex, and you can just call it angle B, and those are going to put a little angle sign. Sometimes there'll be a number inside the angle. You can also name it by that and say angle 4. Because sometimes we're going to see stuff like lots of lines together, and they'll name these like 1, 2, 3, 4, 5, 6, 7, 8. Because it gets complicated to put all those letters, and they ask you to solve a bunch of stuff. So that's why they might be numbered. Okay? And then they talk about angle bisectors, but there's not an angle bisector in this one, but we could draw it in, I think. Makes two congruent angles. So we're going to draw our own angle bisector in here. And I'm going to call this D. And again, you don't always trust the picture. Just because it looks congruent doesn't mean it's congruent. How do you know it's congruent by looking at a picture? Just like with the sides, they can put the little dashes on it. For angles, if these were congruent angles, they would make little arcs, like the same arc, like one arc or two arcs, to show that those are the same measurement. Or they would tell you in the directions that it's a bisector. I bet you've talked about these before, right? Special types of angles. I know you've talked about this because we've talked about Pythagorean theorem. An angle that makes 90 degrees, show with a little square, is called what kind of angle? A right angle. Right angles are really important when building things because if your building does not have right angles, it's going to fall over or be slanted. What about an angle between 0 and 90 degrees? What's that one called? Acute, because it's just a cute little angle. And then angles that are bigger than 90 degrees but less than 180 degrees, what are those called? Obtuse angles. Obsolete, not obsolete. I don't know where my protractors are. I like someone's suggestion of me not dropping protractors on the ground every day.
I got a suggestion. Don't drop perfect.
I like reading those. They're fun. Questions about that? I know maybe the naming part is something that's kind of new, but hopefully you're somewhat familiar with types of angles, right? So maybe you're not.
I just got familiarized, so.
Okay. See, look, that's what I mean by naming it. Look at that picture.
Yeah. So tricky. Thought it was funny when I
So it says name all angles that have B as a vertex. Name all angles that have B as a vertex. There's a lot, right? So what's nice about being on your notes is you can actually draw on them. So Mackenzie, give me one. Angle B. That takes care of this angle right here, right? And technically you could write it another way for that angle, right? Like you could actually say ABG or, but since we've already counted it once, we're not going to count again. Can someone give me another angle that has a vertex of angle B? Or is there another one? Eric?
wait, no, never mind. That's not right.
Audrey? Would angle 7 have a vertex at B? Yeah, we could also call it angle 7.
Sure.
But it still has, its point is at B. Angle 6. and angle 5. So that's why sometimes writing numbers in there is helpful, because really that vertex B is for all of those. Does that make sense?
That make
Yeah.
the other one's problem too, like angle 6, that's a problem.
No, because the point B, it goes for everywhere, right? But angle 6 is just naming that angle that's right here. Does that make sense? If this was labeled 1, we could call that angle 1, and it only names that angle. Okay, that's a good question. Okay, I'm gonna erase this. Name the sides of angle 5. And remember, the sides of an angle are made up as rays, so you need to write it that way. So somebody tell me what the sides of angle 5 would be? Angle 5 would be right here, yes?
Oh, see.
So Chandler, give me a side or sides.
Do you want us to have it ray or segment? Because the kid also.
An angle goes on forever, so you have to say it as a ray. Because I agree, GB stops, but you need to say that it's a ray.
Okay, so then ray BG and ray BE.
Very important that you say B first, right? Could you also say ray BF instead of ray BE if you want to?
Yeah.
That is the correct answer as well.
So we put all three of them on there?
You could, but you don't need to, right? You only need 2 sides, because B, E, and BF are the same line. And then we kind of already did this. What is another angle for angle 6? Eric?
7. Sorry.
Okay.
No, never mind.
Not 7, right?
Um,
So,
11. It's not funny.
one answer would be, could we call it angle B?
Yeah.
We could call it angle B. Can someone give me another name we could call angle 6 besides just angle B? To name an angle with 3 points.
Or DBE. Or DBE.
E, B, D, E, B, D, D, B, E, F, B, D, right? So be really careful. The numbers only go to each one angle, but the letters can go for more than one angle. Okay, so be really careful on that. How do you feel about that? Okay. Lots to remember. So this one says measure angle TYV and classify it as right, acute, or obtuse. Before I hand you this, I want us to just look at it and see if we can think about, does it look like it's 90 degrees, less than 90 degrees, or greater than? And then we can actually talk about measuring it. TYV, so Y is in the middle. TYV. Oh, I hear lots of obtuses.
Nah,
Those lines are really
that's right. That's a right angle. I'll tell you. It's a right angle. You can draw a square in the corner. That's a right angle. That's a right angle. I'm telling y'all right now, it's right angle. So y'all
Okay, I'm going to go to the next slide because I think I have a big protractor on here. Nope. Okay. Is this the same picture that's on the one you just did? So here's the thing when you're measuring, okay? Everyone pay attention. When you're measuring with a protractor, there's a center dot there. The vertex of your angle has to go through there. And even more importantly than that, you see the little straight line that goes out on either side of it? That needs to match up with your angle. So if I was going to measure TYV, right? I have to take this, and I can't just set it like this. Well, I mean, I guess I could. If I set it at the bottom like this, you would have to do some subtracting. Does that make sense? Like if I set it just straight across like this, you could measure Like, you could measure this line to this line and then subtract those two numbers. Does that make sense what I'm saying? So, like, you can't just measure from 0 if you're not going to match it up with one of the sides. That's what I think. I would always just match it up with one of the sides. So, that little straight line at the bottom, I would take my protractor and I would, much easier than I'm going to be able to do, I would match up the vertex with one of the sides. And I chose to match it up with this side. Do you see what I'm saying there? So, like, you have to turn your protractor, and the line at the bottom needs to match up with one of the sides of the angle that you're measuring. Does anyone not understand what I'm saying? And then you measure, why are there two numbers, right? Like there's a 10 and a 170, right? A 20 and a 160, because you might be measuring one or the other. If I'm going to measure like this and go in this direction, do you agree that I would be starting at the 0 and not the 180? So you have to think about which one you'll be using. And then you want to match that up. Look at this fancy protractor. You want to measure that to the other side. And again, mine might be a little error. Mine says 88, but I think it's supposed to be 90 exactly. What do you think?
Yeah.
Did you get 90 on yours?
Yeah. There's a little arm swinging thing.
Oh yeah, the arm swinging thing is nice.
Yeah.
I don't think I have any like that.
That's terrible.
This one I think was supposed to have an arm swinging thing, but it's broke off.
I used to have one with an arm swinging thing.
Does everyone see that the answer should be 90?
Yes.
So be careful on those, because you wanted to say obtuse because you were counting from W instead of all the way up. Okay, so I'm going to go back for a second. So I think we would say it is right.
Got it right.
So now I'm going to give you a second
Got it right.
to kind of look at your picture and use your protractor. I said name an angle that is right. We just did one, but you could give me another one. One that's acute and one that's obtuse, and then use a protractor to give me the measurement that you found for each one. So you probably could just look at this and find me an acute, an obtuse, and a right. But then I want you to practice using your protractor, and then I'm going to have a few people give me some examples of what they said for their answer, and we will agree or disagree with them. And remember to name it. I would probably say you want to name it with 3 letters, because if you just say angle Y on these, all of them would be angle Y, right? So use 3 letters.
Then you can never be wrong.
Then you can never be wrong. And if you need some help with your protractor, let me know. Raise your hand. And I can come over and help you. And again, on a real test, if I was going to make you measure something, there would be a little room for error, right? A couple degrees either way. I would count right, just for room for error. But you want to try to line it up with that straight line at the bottom. There is actually. It's called precision.
But precision would be no error.
Right, but we skip the little in-between section? Here, I'll have to show you. Measuring is not precise.
It's really tricky.
Absolute error is what it's called.
If there was absolutely an error in those calculations. Oh. What you gonna do with my rapid rhyming skill? Yo.
See, the problem with this is it just kind of moves every time I let go of it. It moves. That's annoying.
Doesn't work with your mechanical pencil. It only works with.
All right, who can give me an acute angle?
Can you?
Mackenzie.
Angle WYX is acute.
WYX. That would be this one down here, right? So I need to move my right here. How about I just take your measurement? What'd you get?
50 degrees.
Did anybody else measure that one? This would be much easier on a chalkboard. For certain kinds of technology, it's not. Oh yeah, I think that would be 50. If that's 0, measure up to there, it's about 50. Anyone find an obtuse angle they want to share with me? Eric?
Angle SYV.
Angle SYV.
There.
SYV is like starting here. Definitely, I agree that's obtuse. And what did you get as your measurement?
140.
And so this would be one, if you start and measure backwards, this would be where you'd want to take the bigger value there, right? Because 140 and 40 are together. How do you know which one to pick? Well, SYV, you'd be measuring back like that, and that would be about 140 degrees. Stop me if you disagree with this, or if you have a question of where we're getting these values. And did you all just take the one from up there, or did you pick me a different right angle?
I picked another one.
I would have picked the one that was labeled already. Did you pick that one?
No, I picked one that was
What did you pick?
picked angle stew. STU. Stew. Yeah.
STU?
SYU, but yeah, it would be SYU.
Okay. I was like, how do you get STU? SYU is definitely right. Mackenzie, what did you pick? UYW, that's definitely one. And I would have picked the one that already had the box next to it because I didn't have to measure it because it told me angle VYX is also right. You agree with that? So sometimes right angles are tilted a little bit, but if you measure that, that would also be a right angle. So if it is, unless there were any other. Okay, stop spinning our program.
Okay.
All right, I think this goes for the same picture. Why don't I have the picture over here, James?
Good thing it's plastic.
And it's shattered. Not cracked. Cracked me upside the head.
I have no
Cracked the whip.
Okay, what about this? What if they give you values like this? Ray YT bisects SYU. Angle TYS equals 2x minus 24, and angle UYT equals x plus 16. Find x and the measure of SYU. Yes, you did. You just have to take a piece at a time. So first of all, Ray YT bisects SYU. So what does that mean? Not just goes through it. Bisects means cuts it in half. Okay? So we know that this is now equal to this. It looks like it, but now we know for sure. Angle TYS is 2x minus 24. So can you find that angle? Angle TYS. TYS. Fill it in. I'm going to write 2x minus 24.
That's equal, right? So that one's right there. Same thing, right?
It should have to equal the same thing. They tell us it's x plus 16, but yes, it should equal the same thing. Which means I guess you could say 2x minus 24 again, right? Or, that would be hard to solve that equation. If it bisects it, are we saying this is equal to this?
Yeah.
So is that my equation? Can I just say this equals this and solve that for x? Or we can figure out, we'll find out for sure now if our measurement was right. We're saying this is 90 degrees, right? Who said that? Did you say that right away? One of you said that. If it's 90 degrees, we should get that each one of those is 45. But now we'll figure out, what if it was 89 degrees? We're going to find out for sure right now when we solve this for x. So we know bisects means they're equal to each other. I can tell you that in geometry, they're going to give you lots of words to go with the picture. Don't get overwhelmed by it all at once. Take it a step at a time. And just label it, or draw the picture, fill it out, and think about what it means. So if I subtract the x over, that's just going to be x, right? And I add 24 over, So what happens when we plug 40 in each one of those?
Let's
So it's
go.
not a right angle.
TYS. U.
256.
Yeah.
Pretty sure.
So what happens when we do SYU? Was it really 90 degrees? That doesn't even look right, does it? That means it's 112? Is that right? Is that what that gets when we do this? So again, let's keep some things in mind here, okay? When they actually ask you to measure with a protractor, we're going to measure what the picture says. When they give us stuff with algebra, we have to trust the algebra and realize that sometimes the picture might not be drawn to scale. Because looking at that picture, it does kind of look like it shouldn't be 112 degrees. You agree with that? But the math tells us so, which means the picture, don't trust the picture. Okay? Okay. Not drawn to scale. That's what I need you to remember for geometry. I want you to, the one lesson I want you to get from geometry when you leave this class is don't trust the picture. Don't trust the picture. Well, if there's X's in it, yes, don't use the picture to label it. How about this? When I teach trigonometry, every time I draw a triangle, I draw it like this. Every time, and then sometimes I label stuff like this, 140 degrees, 30 degrees.
Okay.
That's not right, right? But it doesn't matter. Trust what I wrote, don't trust what the picture says. That's what I mean by that. I can still use the picture to label stuff, but that's definitely not 140 degrees. 30 degrees. Alright? Alright, that's my protractor. I think we're almost done, right? Congruent angles are angles that have the same measure. We've kind of talked about that already. And matching arcs on a figure will show that. And so I just threw that in there, kind of just like the last example. If they tell you that it's an angle bisector, you can label it accordingly. And we could even say that angle MPN plus angle NPR has to equal what? Kind of just like the segment thing, right? The segment bisector, you can add them up together and equal that. And we can even say angle MPN plus NPR have to equal each other, even more importantly, if it's a bisector. All right, so use that kind of knowledge as you're doing that. I'm done a little bit early, one, because we didn't have a homework quiz, but the other reason is so that you can actually use your protractor to answer some of the questions on your homework. So when it says measure with a protractor, that's when you trust the picture because you're actually measuring it. But if you're not doing that, then you don't use protractor. You're going to do, this is homework 1-4. You are going to do numbers 12 through 33 every third problem. 30 and 33, you do need a protractor. So if you want to start with those, you can. It might be out of your comfort zone to do your homework out of order, but you do need a protractor for 30 and 33. So my advice is use your 9 minutes that you have left to make sure you at least get those two done. Tomorrow we're going to go over this homework. We also can construct an angle and an angle bisector using our compasses and our protractors. We'll do that tomorrow. And we're going to review for our quiz tomorrow. So, big day. What's wrong with yours?
Well, my glossary is in a packet that was stapled together, like so. And then like half of the pages just fell out of the back.
Yeah,
And they're
missing
all
3
just
selected papers. Which are the ones like that we were doing the other day. And I really honestly could not figure it out. So it's like, well, I'm just gonna see if it's got what they did.
Mrs. Sumter has extra books. I'll look and see if she has any that are worth getting. They might be in worse shape. Okay? The good news is really soon we're going to have the Chromebooks in here, and I haven't got it yet, but I'm supposed to get a copy of the student edition, like on CD, and I can upload each chapter online too, because we're going to find as we go through these books, some people not only are missing random selected answers, they're going to be missing pages out of the book. So having that online guide will be a nice thing too. So
Like the answers like the blue thing in the back, 'cause I don't have that.
probably
Go on.
It's done.
the first ones there, you're just naming stuff. But again, 30 and 33 are like the ones that we did that say classify as right, acute, or obtuse, and use a protractor to measure. So 30 and 33 you might want to look at really quick, and you could at least write down what the measurement was. Otherwise, when you come in tomorrow, you need to get the protractor and do it while you're doing bell work. And then you can put your protractor back up here.
I got a smiley face.
Hey, me too. I know.
Smiley faces are us.
And I do have grades updated. I don't know that I made it by, I think I had it by 5 on Friday. But remember that if you want to retake a homework quiz, that you can do that before the test. So we're probably going to be having a test next week, so keep that in mind. So the vertex is just like a point, right? So angle 4, Q. I think you can just say Q, because it's just a point. If you wrote angle, I would have marked wrong. But I think when it asks for the vertex is just a point, so you can just say the point. You don't have to put the angle symbol. Get them with your protractor, you can leave them on your desk, I can pick them up, or you can put them in here on your way out too. Wait, I'm still recording.